Hi guys, Miss Marflag here. We're going to get started on a new lesson today. I did write up here the previous lessons we've done. That way you can kind of keep track of the packet. You're going to notice that the packet that we're doing this week is going to say 8-5 and 8-6. So I have checks here. You know, we already did exponential functions. We did the introduction to our logs, evaluating, converting. We did our properties, and then now we have 2 lessons to go until we're kind of done with this whole log chapter, exponential and log chapter. So here we are highlighted for us. We're going to be working on today 8-5 exponential and logarithmic equations. Now this 8-5 will take us probably 3 days or 3 videos. We're really just going to be focusing on exponential equations today, and then we're going to see log equations in our next video. All right, so here we are, start off for us, exponential equations. And my first question is, well, you know, before we get started on how to solve them, we need to know what an exponential equation is. And our exponential equations are going to be any equation where the exponent is or includes a variable. All right, so it could be any variable. We're going to primarily be working with x, but in theory, it could be a y, it could be a z, it could be a b, it could be any variable, but the exponent includes a variable. So an example here, you know, for us would be like, I don't know, 3 to the 2x is equal to 4. Well, that is an exponential equation. So I'm going to write yes, that's an exponential equation, because our variable here is in the exponent spot. But then when you have something like this, you know, maybe 3 squared is equal to x. This is not an exponential equation. That's a no. You could see that the x is not in the exponent's place. Now with these exponential equations, we're going to primarily have 2 types, and we're going to be working with these 2 types. The first type here is going to be when we can get the same base on both sides. So if you can get the same base on both sides and then use property of exponents to solve, that's usually a little bit easier. But we do run into some problems with those exponential equations when you can't get the same base on both sides, and then that's where our logs are going to help us. So when we have no same base and we cannot get the same base on both sides, that's when we're going to use our logs to get that x out of the exponent. Now, I know that maybe doesn't make much sense right now, but we're going to start off and we're going to look at this first type, and that's going to be with our same base. And we're going to start the numbering here at 1, and our directions are going to be solve. So here we are, number 1, and our directions are to solve. Now, solve means we're looking for that variable, and here I am, 2 to the x is equal to 64. Now, I know you could probably count on your hands and see, you know, what x is, but I'm going to use our property of exponents here, and we're going to rewrite this. Well, I want the same base on both sides, so I'm going to rewrite 64 with a base 2, and that's going to be 2 to the 6. And then now that you have the same base on both sides, you can go ahead and use that equality property, and our exponents are equal. And there we are, we're going to get x is equal to 6. Moving on to the next one. This one you probably can't count on your fingers. It's a little different. I see a 32 and an 8. Now my goal is to solve for that x. I want to get the same base on both sides, so I want to rewrite the 32 as something and rewrite the 8 as something, and that something is going to be 2. All right, so I need to know 2 to what power is 32? Well, that's 5. So I'm going to take out that 32, and I'm substituting in 2 to the 5th. And I still have to that power x. And then I'm taking out 8, and I'm substituting same base here, and that's going to be 2 to the 3rd. When we get better, we can skip this step that I'm doing right now. But for right now, we're going to throw this step in here, and we're going to see that power raised to power, we multiply. So that's a 5 times x. And then now same base, we can get rid of the bases with equality property, and then we can go ahead and just solve for x, and x here will be 3/5. All right, moving on to the next one, number 3. We're going to have 4 to the 2x minus 1 is equal to 64. All right, we're still working in this first type of exponential equation, so my goal is to get the same base on both sides. I see I have base 4 and base 64, so I want to rewrite that 64 with base 4. And I know 4 to the 3rd power is 64. Now you can go even smaller if you'd like. You can go to base 2, but that's a lot of work. The goal is just to get the same base. It doesn't have to be the smallest base. It doesn't have to be you know, it could be any base that kind of makes your life easier. See, I don't have to change this side. I'll just make this into a 4. And then now we have that equality property, and I'm left with 2x minus 1 is equal to 3. And then when I go ahead and I solve for x, I add 1 and I divide by 2. I'm going to get x is equal to 2. All right, hopefully we're comfortable with those 3. We're moving on to number 4. We're going to have 3, 1 minus x is 1 over 27. All right, so my goal is to get the same base on both sides. I'm going to leave that 3, which means I want to rewrite this side with the same base as 3. Well, I know how to rewrite 27 with base 3, and that's 3 to the 3rd. All right, and then now I'm going to use those property of exponents, and I'm going to bring that 3 to the 3rd up in the numerator using that inverse property, and my exponent switches signs. And then now I have the same base. I can use my equality property, and I can go ahead and solve for x. We can subtract 1, and then we could divide on through by that negative, and we're going to get x is equal to 4. All right, moving on to number 5 here. 5. Can I squeeze it in? Yes, I can. 6 to the x minus 3 over 4 is equal to square root of 6. So you can see as we go on and on, the problems are getting a little tougher, but the process is still the same. I want to get the same base on both sides. Now they do look like the same base, except that this is a radical and I need it to be written as an exponent so that I can use my equality property. So I'm going to rewrite that square root as 6 to the 1/2. Keep in mind power, 6 to the 1st power over root, and the root is 2. Now that I have the same base, I can get rid of those bases. I'm going to be left with x minus 3 all over 4 is equal to 1/2. And then we're going to solve here using our cross multiplication. So I'm going to multiply these two, and I'm going to multiply these two. I'm going to have 2 times the quantity x minus 3 is equal to 4 times 1, which is going to be 4. I do have to distribute that 2. That's the important part. And then I can go ahead and I can add 6 to both sides, giving me 10. And then I can divide by 2, and that'll give me x is equal to 5. And then, you know, if you want to just double check here, you can just mentally plug it in. Well, 5 minus 3 is 2. 2 over 4 is 1/2. 6 to the 1/2 is equal to square root of 6. And there we are. All right, we have 2 more to go here. We're going to take a look at number 6. We have 4 to the x is equal to 1 over square root of 2. All right, so this one's very similar to number 5 because we do have this radical now. So my first step is going to be to write that radical with the exponent. So I'm rewriting that square root of 2 as 2 to the 1/2. And then just like we did over here, bringing it up into the numerator and making that sign, changing the sign of the exponent, we're going to do the same thing here. And I'm bringing that 2 up to the numerator, and I'm changing the sign of the exponent. All right, and then now we're almost there. It's almost looking like we have the same base on both sides, but I do need to rewrite my 4 with base 2. And I know that 4 is 2 squared, and I still have that x there. And then hopefully we can skip this step now, and we have the same base. Power to power, we multiply. Well, that's going to be 2x is equal to negative 1/2. And then we can divide on through by 2, and that's going to be x is equal to negative 1/4. And then you can double check with a calculator, plug it in, get a decimal, and then take this quantity, get a decimal, and you're going to see the decimals are equal. This would be a good time to pause and make sure you have all of these 6 examples. We're moving kind of quick. We do have one more to go with this type of exponential equation. I'm going to flip the page, or I'll start on a new page here, and that's going to be number 7. Okay, here we are, number 7. Now we have e to the x plus 1 is equal to 1 over e. All right, keep in mind that e is not a variable here. It is an irrational number, just like pi. So this is a number, so the only variable we're solving for is x. So my goal is to get the same base, and we're almost there. We have e on both sides. I just need to bring this e up into the numerator, and that's going to be e to the negative 1. Now, even though you don't see it when we started this problem, this was e to the 1st, and then that's why when I brought it up, it was a negative 1. All right, same base, we set those exponents equal to each other, and I go ahead and I solve for x, and I get x is equal to negative 2. Kind of just mentally checking here, well, negative 2 plus 1 is negative 1. E to the negative 1 is equal to 1 over e. That looks good. All right, so those were our examples of our first type of exponential equation where we can get the same base. Sometimes that's easier, but this where you don't have the same base, which we're going to look at now, this is like the quadratic formula in the sense that, it always works. Always works. So this method we're going to look at, you could have used with all of these examples, but sometimes it is easier when you can identify that you can get the same base on both sides. Now looking at our new type of problem here, not same base. And we're going to start this numbering all over again. Our goal is still to solve for that variable. Looking at a new type of problem, number 1, 2 to the x is equal to 3. Now there is no way that I'm going to rewrite 3 with a base 2. Not in a way that's easy for me, not something that's kind of off the top of my head, so I can't get the same base here. But I need to solve for that x. That's my goal that I want to keep in mind. And I can't solve for it when it's in the exponent place. I need to get it out of the exponent place. To get that x out of the exponent place, we have a property that does that. That's our power property of logs. But I don't have logs here, so I'm going to take log on both sides. What I do to one side, I have to do to the other so that I can ensure I'm not changing the value of this equation here. Or you can think about it, okay, when you're solving maybe a simple equation like, let's say, x plus 1 is equal to 2. You do the inverse of the plus 1. Inverse of plus 1 is minus 1, and you do that to both sides. Right? Well, the inverse of exponential is log, and that's why we're doing it to both sides. Now, you can use any log that your heart desires. Some people use natural log if you're looking on Khan Academy or if you're looking online. We're going to be using log base 10 in this class, and that's kind of the easiest because we do have that button for us on the calculator. All right, enough talk about strategy. Now that we're here, I took log on both sides. Now I see this, and I can use my power property and bring that power to the front. And then now this is super helpful because now that x is out of the exponent place. I do need to still solve for x. This is joined with multiplication for that power property, so I'm going to undo that with division. And here we are, log base 3 over log 2. I'm a-okay with you leaving this as your final answer, but if you do have a calculator handy, you can go ahead and give me the decimal approximation. I'm rounding here. Now, it's very important that you do log 3 divided by log 2. You cannot do, okay, so this is a no, you cannot do log 3 over 2. They are not the same thing. You're not going to get the same answer. All right, moving on to the next one. Here we are, number 2. We're going to have 9 to the 2x is equal to 66. All right, just like number 1, there's no way I'm going to get the same base on both sides. I'm not going to get the 9 to be a 66. I'm not going to get the 66 to be a base 9. I can't get them to base 3, none of that. So I'm going to go ahead and I'm going to apply log on both sides. So that's my strategy here when I don't have the same base. Now that we have log on both sides, we can get that exponent out of the exponent place using the power property. And then once that x is out of the exponent place using the power property, we're just solving for x. So I want to get x by itself here. This may look a little weird, but instead of dividing by log 9 and then by 2, I'm just going to divide by both of them at the same time. So I'm going to divide by 2 log 9, and I'm going to divide by 2 log 9. All right, that'll get rid of my 2, and then I'll get rid of my log 9, and then my x is by itself. So x here is going to be equal to log 66 all over 2 log 9. And then when I go ahead and do the decimal approximation here, rounding as well, I get 0.41. All right, good time to stop the video. Shifting now to number 3. Or we're going to have 4 to the 7x equals 250. If the last example made a lot of sense, you can go ahead, skip this example, and look for the part in the video when I label 4 here. All right, this example is just like the last one. We cannot get the 4 and the 250. Maybe we can, but it's kind of hard to think or count on your fingers. 2 to what power is 250 or anything like that. So we're gonna go ahead and we're gonna apply log to both sides. All right, it's not easy enough for us to maybe think of the same base in our head, so we're going to go ahead and do log on both sides. Now that I have log, I can get that exponent out of its exponent place using the power property. And then I can go ahead and I'm going to solve for that x now. All right, looking here, I want to solve for x, get it by itself, so I need to divide by 7, and I also need to divide by log 4. Now you can tell that these are multiplied together. There's that multiplication sign. The 7 is multiplied with the x, so I undo it with division. What I do to one side, I also do to the other. I'm going to have 7 log 4 in the denominator of the other side. You can see here that I'm going to get x is equal to log 250 all over 7 log base 10 of 4. And then when I go ahead and plug this into the calculator, I get about 0.57. Make sure you try some of these on the calculator. Make sure you're getting these answers because you're going to be expected maybe to give me a decimal approximation, a multiple choice, and an upcoming test or quiz. All right, so make sure you know how to use a calculator and that you're typing in log 250 divided by the quantity 7 times log 4. So this really needs to be in parentheses, or it'll do this divided by this and then multiply by that. So make sure this is in parentheses. All right, moving on to number 4 here. We're going to have 2x plus 3 is equal to 512. All right, now we can probably think of 2 to some power. That'll give us 512, but we're going to keep it going with this same method that we learned. It's maybe not easy for us. It's easy to think of 16, 32, 64, and then anytime the number gets bigger than that, you're kind of counting on your fingers. So we're going to go ahead and use our log on both sides. So I'm going to apply log to both sides here, and I'm solving for that x. I need to get it out of that exponent place, so we're going to go ahead and use that power property, and I'm bringing that power to the front. Now that power is not just the x, it's also the plus 3. So the whole thing is my exponent. So that whole thing is coming to the front. Notice how I'm keeping it in parentheses here. So it's not confused with maybe 3 times log 2 and then add x. No, this is one quantity together. So that exponent needs to go in parentheses when you move it to the front using the power property. And then we have what's on the right-hand side here. And then I'm solving for that x now, and I'm dividing by that log 2 all over log 2. And then I'm still solving for that x, so I'm going to subtract 3. Solving for the x, subtracting 3. Minus 3. All right, and that's exactly how you're going to be plugging it in on the calculator. You're going to do log 512 divided by log 2. You're going to subtract 3, and you're going to get an exact answer this time, and that's going to be 6. That's going to be 6. And then, like I said, there probably was some, power that we could have raised, and we could have saw that that probably was 9, because look here, 6 plus 3 is 9. So 2 to the 9 would have given us 512. All right, and then, but here is the method that does always work. All right, keep sticking around. We're almost done. I think we have, how many more? 2 more. That's not bad. 2 more examples. And here we are, number 5. We have 2 to the 3x minus 4. That's all power. Minus 1 is equal to 4. Okay, now we can see in all the other examples we did, the term that had the variable exponent was by itself, right? It was all by itself. Now it's not by itself, so that's going to be our first step, and our first step is to isolate the term with the variable exponent. So I need to get this term by itself, so I'm going to go ahead, and the first thing I'm going to do is I'm going to add 1. All right, once the variable, the term with the variable in the exponent is by itself, then you can start thinking strategy. Well, can I get the same base? No, I can't. Okay, now I have to apply log on both sides to get that variable out of the exponent place. Log on both sides. And then now using that power property, my whole entire exponent is coming to the front there in parentheses. The whole exponent is coming to the front. And then I can solve for that x by dividing by log 2, log base 2. And then the order of operations is important here. Now we're going to add 4 log 5 over log 2. The whole thing we're going to add 4, and then I do have to come up over here. I was going to save this space for number 6, but that's okay. And then now I have to divide everything by 3. I'm just putting a line here because this is the work from number 4. All right, coming over here, now I have to divide everything by 3. So I have log 5 over log 2 plus 4 all over 3. You can leave your answer like that, or you can go one step further and you can put that 3 in there, and here we are, plus 4 over 3. So either one is fine, or you can give me the decimal approximation, and when you solve for the decimal, that's going to be 2.11. Now, if this is really confusing, if your algebra right here is not that strong, that's okay. Go back to this step and go in the calculator and do, log 5 over log 2, get a decimal, add 4, you'll still have a decimal, and then divide by 3. Okay, so then do it in chunks, do it in little pieces if you're not comfortable with doing this algebra here. All right, I thought we were going to be able to save paper, but we can't. Oh, maybe I'll come up over here. That's what I'll do. I'll come up over here. The Smart Flash trying to save the environment. We'll draw a box here, and we're going to do this last one up at the top of the paper. All right, this one's going to be number 6. Last one. 6. Okay. Now we're going to have 7 minus 5, 2x minus 1 is equal to 4. All right, believe it or not, this one's just like number 5 in the sense that you have this exponential equation and you don't have the term with the exponent variable by itself. So the first goal here is going to be to isolate that 5, 2x minus 1. So I'm going to subtract 7 from both sides, and 4 minus 7 is -3, and then I'm going to divide on through by a negative. That way I don't have to deal with a negative in the log. Keeping in mind the domain of log is that domain has to be greater than 0, so you can't apply log here. You do have to divide by negative. All right, now that that term with the variable in the exponent is isolated, I can go ahead and I can apply log on both sides. Applying log on both sides. Oh no, my pen is running out of ink. We did way too much work today, right? That's why my pen's running out of ink. No, I'm just kidding. Okay, but you could see this clearly enough in the video. I'm going to keep it going with the blue now. So we apply log on both sides. I'm going to bring that exponent to the front using that power property. Bringing that exponent to the front using the power property. And then I'm solving for x, so I'm going to divide on through by log 5. And then if you'd like, at this point, you can start using the calculator, doing things in chunks. All right, but I'm going to keep it going with the algebra. Still solving for that x. I have log base 3 over log 5, and I'm going to add 1 to both sides. And then I'm going to divide on through by 2 here. Divide everything by 2. And then now you could have either done it in this step, or this one, final one here, plug it into a calculator, and you're going to see your answer is 0.84. All right, and there we are. We're done for today. Now, I know that this was a little bit of a longer video than maybe we're used to, but still 25 minutes is not too bad when I usually do a 52-minute lesson. Quick recap, we went over exponential equations today. We still have to do logarithmic equations. We'll probably spend 2 days on that. We talked about what an exponential equation is. We talked about the 2 different types. We first started off with writing the same base if we can, and then we moved on to applying logs on both sides. Now, if this was really confusing for you, that's okay. You just have to sit down, maybe watch the video again, and take a look at the examples. And then if you have any questions, please email me. All right, do your homework and then check in the following day for an answer key. Bye, guys.